Give me a moment, guys. All right, I muted it. So we start. So let me give you a general idea of the code. In the first pass, I'll just walk through the basic structure. This should be the familiar set of imports. The only thing you have to change is wherever you install the code base, download the starter code, change this one line so that it refers to that. Then rest of these are imports. We are importing Gensim, we are importing Spacey, pandas, SQL. Actually, UMAP, I didn't come around to doing it, but I'll show you beautiful visualizations next time with this. Matplotlib and so on and so forth, warnings. So now let's look at this. We load the data. It turns the reason I used sklearn, scikit-learn, is because scikit-learn contains this 20 news groups data built in, right, in its data sets listing. So it's very easy to just go get it. Now, what are the 20 news groups? As I said, it is the emails, about 11,000 odd emails, spanning about 20 different news groups with 20 different topics. So which topics are as follows? You see those topics here. Right now, here is a sort of a homework I'll give you guys. I am spanning 20 topics. What I would suggest is pick 3 topics that to you look fairly orthogonal. For example, you can take uh, sports, one of the sports or 2 of the sports topics, and then take science, let's just say space or something like that, and take one from I don't know, politics or something like that, and just take 3 of the topics. You can do that by putting filter, remove, and then there's a filter clause also that it takes. If you look at the documentation of this, and then you can then do the topic modeling. Here, what happens is we already know the topics, right? So you might wonder, if we already know the topics, we know the 20 things it is coming from, why in the world are we doing topic modeling? The idea is in real life, you won't know the topics. You will try to figure out some good topics in the data. Right? In this particular case, it happens we know that. And so what we'll do as we do the topic modeling, we'll try to see how well the topic modeling algorithms are able to sort of surface or figure out what the real topics were. That's our exercise. So take that. As you can see, it's more or less uniform distribution. Some topics are less. The talk, religion, MESC seems to be rather less, and atheism seems to be less, but not by much. We will, to the first approximation, consider it uniformly distributed. So what I did is you take this data and you just put it in, and again, I'll go a little bit fast because then we'll come back into a slide. I just put it in a pandas data frame to see what it looks like. When you look at this data here, let me sort of increase the font a little bit so you guys can read this. If you look at this, do you notice that it contains a lot of strange, a lot of things which are not really English, but sort of are other things. They are article from a certain article by a certain person, and so on and so forth. So there is a lot of end line, there's that characters here. So one of the first things you do is, and then also you notice that if I look at the topics, there's a lot of overlap, like politics. Maybe you don't want to distinguish between all the different categories of politics, and religion, all the types of religious discussions, talk, and so forth. So what I'm doing is, to simplify, I'm breaking it up into just 6 groups. And I would suggest you can do it with smaller number of groups. But even before we do that, so here's the thing. What you do is you have 20 news groups. Here I'm reducing it to politics, religion, sports, computer, science, and for sale. And here's a hint I'll give you. Actually, one simple exercise you can do is you can merge computer and science. They are both STEM field. So you could merge the two, and perhaps you could merge religion and politics. They, despite all the effort to keep them separate, they all tend to overlap with each other. So you could do that. So you will get fewer number of topics. And for sale, you can add into, I think in this case, it's equipment, cars, or so forth. You can merge it with sports so that you have three good topics and you can try to do topic modeling. Right? So it's just a basic idea. So what I'm doing is for each of the row, I'm adding a new column called topic. And when I do that, you notice that if you look at the columns here, the rightmost columns, the target is what came with the data. And I'm taking another topic, simplified topic, which is now sports, computers, and whatnot. So I'm just augmenting the data with info, so some topics that. So now when you have a data and you try to do any linguistic analysis or so forth, or any kind of a semantic understanding, you know that some things don't contribute to a semantic understanding the semantic structure or the semantics of the data or the meaning of the data, right? For example, the the basic stop words, the, has, this, that, the very common words, you don't want to keep them, right? So every single library that you can think of in NLTK, sorry, in natural language processing, whether it is SPACY or NLTK or whatever it is, they all give you a list of stop words. And quite often the stop words are either derived from or directly the famous Stanford WordNet's list of stop words. So we will remove the stop words. Likewise, we'll remove punctuations. Like now, whether we should remove punctuation or not, it is a little bit of a thing. I decided that in this exercise, we could remove the punctuations. Does email contribute to semantic meaning? Like, for example, does, when you look at this, is it going to contribute in any way to that? It is not going to. So we are going to remove emails. Remove proper, actually I removed that. I kept the proper nouns because then I thought scuzzy and things like that. And quite often they are proper nouns that are worth keeping. So I should change this, remove this from your mind. Lemmatization of the word, would one of you remember what lemmatization is?
Getting to the root word.
Getting to the root word. Now, somewhat conspicuous by its absence is stemming. I am not using a stemming. I tend to use it less often. I prefer lemmatization for many more situations. But, you know, actually, it's more laziness. You should try both and see which helps you more. Now, so another thing is, let us go and clean the text. Before we clean the text, we will use the language model, NLP's English language model. And you remember which model are we talking about? We are talking about the English Core Web Large. If you remember, I suggested always use the large one. I'll continue on. So once you have done that, I'll explain to you what a clean text looks like. I was wondering if anyone out there could enlighten me on this car, blah, blah, blah. Do you notice this thing, right? Now, what does that do if I try to clean this text? Now, by the way, I've given a clean little utility, very simple function to clean the text. Let's go and see what the clean text does. It is extremely simple, actually. It is again, where would you find the NLP libraries? In the NLP, SV NLP directory. So go into utils, and you notice that I'm basically, and this is something you can play with based on your context. Like spaces don't mean anything, pronouns don't mean anything, punctuations don't help much, symbols don't help much. Left and right brackets so you can decide which you want to keep and which you want to remove by commenting or uncommenting, and consider it an exercise that you want to do that. Now, let's look at what we do. what we do is you're giving a token and you're trying to decide whether to keep it or not. And the code is just one line. If the token is in the ignore a part of speech list, punctuation and symbol and so forth, it is not worth keeping. It has not much semantic value. Likewise, if the token is like a URL or it is like an email, or the lemma, when you lemmatize, the length is less than 2. Now, be careful with this. Sometimes, on rare cases, it might have meaning. But here, I just said that, okay, if it is just 1 or 2 letter word, drop it. And if it is a stop word, again, drop it. Right? That is all. So you see how it is. Drop the not so useful parts of speech, drop common words, drop URLs and emails and so forth. And you can have more conditions, but to keep it simple, I stayed with these so far. When you do that, in that one line of code, actually, and this is the power of NLP libraries or NLP itself, it's pretty mature for all the pre-processing tasks. You notice that this thing has become this, right? We could make it even worse. Let us say that I make it this. I say, IO website and instructor at support vectors.com. Let's see. Now what happens? I run this. Do you notice that it has managed to remove all of those things? You could play games. So sometimes the email addresses come wrapped up with angular brackets, and you could do that, and it would still be able to figure it out. It's pretty good at that. And if you read the words that gets left behind, I hope you would agree that these are likely to contribute to the meaning of a text. So will that. So now I just illustrated this function, clean text. Now what do we do? In this data frame, we are going to clean up all this text and create a new field called cleaned text. And in the data frame, the newsgroups data frame, I'm just applying clean text to each row. And yeah, go ahead.
The topics that you assigned earlier to those rows, those are random. If you go up, you go up there, you assign those topics.
Yes.
They're just random assignment.
Yeah, it is my choice. I wouldn't call it random, but it is subjective. You could do your own assignment.
Okay.
Am I clear?
So these, I'm not talking about the group here that you picked, the 7 topics there. I'm talking about the output 7, where you assign those. So that assignment, I said, was it random or?
Output 7, you mean the last one?
The output of the 7th.
Output of the 7th. Yeah, topics here. No, it's not, right? You see, the topics are the ones that we assign, but the target comes from this list in the data itself.
Yeah, correct. The target is part of the data. The topic is something that you assign.
That I am assigning. Yes, very much true. And remember, this is not topic modeling, because here what we are doing is we already are setting up an answer, and then we will see how good the topic modeling algorithms are in coming close to our answer.
Okay. So you know what that line, the text is, and you know what you are assigning. Okay.
Yes. This is by choice. Right? Very subjective assignment. So far, we haven't gotten to topic modeling at all. What I'm doing are standard exercises of NLP, which I hope by now you are all very familiar with. Right. So do, guys, again, to recapitulate, please do make sure you're reading the green book and the green book. The one green book being the Spacey, and the other green book being the Manning, Natural Language Processing in Python. Right? So make sure that you're reading it. And then there's the O'Reilly book. Pick your choice. It doesn't matter where you read it from or whether you're reading it straight from the Spacey website and so forth. The important thing is to become fluent with at least one natural language processing library for all the classical stuff, right? And do it. And these are small libraries. I chose Spacey partly because it's high performance and very small library. It's not like vast like NLTK and so forth, where there's so many things. You get the learning curve for Spacey, you'll realize is very short. So what I'm going to do is we have now
one quick question before we move on. Line 10, you're importing something called EN. Line 10. No, the line is different. Sorry, line 8 in yours. Yeah.
Yes. You remember what is this? This is the English language.
Okay, but
we talked about that.
NLP equal to Spacey.load n. Is that how we do it, or was it a longer string?
No, EN with this.
Okay.
Right?
For some reason I get an error with that. Okay, I'll figure out.
Yeah, you can give the full name if you prefer. You can give it the exact full name.
Okay.
So let's try that.
I think that's what is needed, perhaps. Yeah.
You can do that, and that will also work, right? Yeah, it will also work. So yeah, it's sort of these are variations. Now let's go in here and see what I'm going to do. I'm again not reach topic modeling. I'm just setting up the system so that you can compare the topic modeling results with this. So if I take the data in which I have clean text as the input and the topic as the output, this becomes a case of supervised learning, classification, right? I can train a basic classifier and see that. Now to have a basic classifier, all is well. The trouble is the input must be a vector. And so the only vector space representation of document that we have learned so far are the count vector or the TF-IDF vector, right? So we'll use the TF-IDF vectorizer. We'll convert each document being one row of text, into a vector. Again, simple. Once we do that, this is just an illustration of the kind of vectors each of this becomes, the words become, and so forth. So I won't go into that, this is just illustrative. I added it here. Now, what do I do? This is basic by now, you must be familiar with. If you want to write a basic classifier, what do? You take the data set, split it into test, train, then you take a classifier, you fit it to the data, you make predictions, and then you come up with some prediction metric. So I wanted to do a very quick and dirty result to see what it comes up with. And if you notice, I use a very basic algorithm so that it runs fast. It literally executes in 6 milliseconds. Here, executes in 37 milliseconds, very fast. To get a very rough and ready idea of how good a classifier, how good the classification is, how well are the topics separated. 82% F1 score, that is a balance of precision and recall, I would consider it pretty good. Like 83% is a pretty good separation between the topics. So now, one of the things I taught you is mentioned the Zipf's law for distribution of word frequencies. What the law says, to recap, is that the frequency of a word is inversely proportional to the rank of the word in the corpus. Right, with respect to other words, the frequency rank, right? And so we can try and see whether it is true. Now, it was more than that. F was 1 over the rank to the power n, to the power s, where s could be something. For simplicity, we assumed 1, but all right, that is F's law. Right? Let's just see if that holds in some form. What I do is, you take all the words that are there in the corpus. This is your clean text. You can extract all of the words, and it turns out that they are unique 114,000 words. 289, but let's go with 114,000 words. That's a pretty large vocabulary of words there. So let us see if the Zipf's law holds. What I'm doing is I'm just creating a frequency table, the word frequency, very basic. Then you see what happens is, I happen to know that you'll end up with a very long tail. You will get gazillions of words with, that have occurred only once or twice in the corpus. So just to keep just for the purposes of visualization and no other reason, I deleted any words, I removed any words, at least for the visualization purpose, whose frequency is 2 or less, right? So then I end up with a smaller number, 28,000 unique words. And do you notice something very interesting? We started with 114, and 114 has already reduced itself by a factor of almost, 1/4 or 1/5 it has become by the time we go to words of length 3 or more. I mean, words of frequency 3 or more. That already is suggestive of the sort of Zipfian distribution to some extent, but let's continue that. And then I make the frequency plot. Do you see this 1 over rank kind of distribution? The x-axis is the rank, y-axis is the frequency. I hope you can see the classic signature of a long tail distribution. I've taken only the first 1,000 ranks because otherwise the graph looks, it doesn't look nice. So I just made it like this. And then if you take the log of it, the log of it should have been more or less a straight line. It isn't exactly a straight line. But let's just say that, okay, we'll call it a rough approximation to a straight line. Would you agree, guys, on the right-hand side? Right. Sort of like a straight line, but not quite a straight line. So it is a very rough approximation to the Zipfian law distribution. So that is that. I'm illustrating the fact that Zipf's law of frequency distribution does hold. And that is the reason why, remember in the TF-IDF definition, for the IDF, we take the log, right? Just to linearize things a little bit. Okay, now we come to the topic modeling with Gensim. Now, guys, we know enough about the data. So we will start the main thing that we want to do, which is topic modeling. We use a library called Gensim. It's a fairly popular library in the Python world for topic modeling, and does a pretty good job. It's written in C underneath it. So it's a fairly high performance implementation. What does it need? It basically needs an array, a list of documents, each document being itself a list of tokens, list of words. So it is a list of words, right? In some sense, a two-dimensional array, a two-dimensional matrix of words. So what I'm doing is I'm just creating it like that for every text. First thing, do you notice that I'm using NLP? Where is this NLP coming from? SpaCy, right? This thing, we must be familiar with the previous week's lab. We get to the words, and one of the things I'm doing is token, for token in dark, if token.text, in keep words, I'm creating a list of words which are frequent enough, at least thrice they have shown up in the corpus, and keeping those words. And then when I have that words, I'm looking at the very first sentence and first email, and it decomposes it into this wonder, enlighten, car, sea, two-door, sports, blah, blah, blah. Now what you do, you realize that the words that we found in the corpus are a limited subset of the words in the entire English dictionary. We have about 28,000 words. So we will create a limited dictionary of only those 28,000 words, right? So that our TF-IDF, that the vectorization is not irrationally big. Okay? So we do that. Now, when you do that, you do it using a dictionary. You give your text and you create a dictionary. This is a Gensim thing. And now you have a dictionary, and it says that there are 28,000 unique words. It starts with these kinds of words. Now this dictionary, by the way, has a way. Remember that I removed, for the process of visualization, I removed the infrequent words, once or twice words. Now, it's because I did visualization before, so I removed it. But usually, if you haven't done that, then Gensim gives you a way to remove these uncommon words, filter the extremes, the very common and the very uncommon. is there. It contains a feature called filter extremes. We are not going to use it because we know that we have already sort of removed the stop words, which are the common ones, and removed the rare words. So I skipped this step. But as a homework, you can consider implementing it and seeing how it affects. So now comes this. Very simple. We have a list of words. Now we are going to create a Gensim model. So when we create a Gensim model, first it's a two-step process. We create a bag of words. Remember, bag of words was what? That long representation in which one hot encoded sort of a representation. Given a word, what is, whether it's present or not, and so forth. So you create a bag of words, a representation of the word, of the each word in the dictionary, and then you feed it into the TF-IDF model. Now, remember one thing, guys, that you can do the TF-IDF vectorizer. Every NLTK, every natural language processing toolkit will give you that. This is the syntax for Gensim. There is, if you just look at scikit-learn, there the class is literally called TF-IDF vectorizer. Right? There, once again, you would give it the bag of words and it will do that job for you. So these are just minor differences in syntax, and I won't go over it. It's something that you become familiar as you do it. Then I talked about the singular value decomposition, that you could do that linear decomposition into latent topics. Here, I've taken the number of topics to be 6 because we happen to know the answer, what is a good number of topics. But in reality, you'll have to play around and see what gives you good topics. So we take these topics and then we look at the topic. I let the LSI or LSA do the modeling. The modeling is very simple. Do you notice that this is just one line? You give it the corpus, TF-IDF corpus. Now, when you give it the corpus, TF-IDF is based on a word's index in the dictionary, which not very readable. It is much better to contain the actual words. So the ID back to dictionary, you can look for that in the dictionary, and the number of topics is 6. And then you go and run it, and then what happens? You ask it to print the topics and the important words found there. So let's see if it makes sense. Let's look at this one. Topic 0. No people think, like, good, use, problem, thanks, work. Well, I don't know. Can you guys infer what it is? Probably hard. The second topic is file, card, drive, thanks. There's God. And then there is Windows, people, driver, window, desk. Can you guess what this could be amongst the topics here? Topic 1 could be what? Anyone's guess?
Religion?
Religion would probably not have Windows in it. No, Windows.
It looks like something to do with operating systems or
Yeah,
computers.
probably could be computer.
Computer, yeah, computer, yeah.
But it's not very clean because it has the word God in there and so forth. So topic 2.
It's negative, right, on God?
Yeah. Negative, but negative doesn't, it's the size that matters, the magnitude. It's still pretty.
Oh, okay.
Now, the topic is key, game, team, chip. That also seems it has game and play, maybe sports, perhaps, or may not be here.
It says chip, so could be gambling too.
Chips could be gambling, yes, but it has encryption, which maybe science. So it is. So the topics don't seem very easy to see. Topic 3 has game, God, Jesus, chips, encryption. So you can see, and government also thrown into it. Never a good idea to mix God with government, isn't it? So, well.
Asif, in this, did you have a constraint in terms of how many topics it will use?
Yes, literally that. If you look at it, you can change the number of topics. And this is one thing you should do, guys. I would strongly encourage you to play with the number of topics. Try 3 topics and see what happens. Hint, that's a hint actually. Change this code, make it 3 topics, then see what you get. All right. And you'll see something worth it. Then So it's hard. This one seems to be religion, quite definitely religion, right? Chastity, skepticism, shameful, intellect. Oh, may or may not be. Surrender, banks, God. But there seems to be God everywhere. So a bit hard to tell. So that was the latent semantic analysis based on linear, this singular value decomposition, which is sort of a linear factorization process. Now, perhaps that didn't give us as good a result. Let's try the latent Dirichlet allocation, the one that we are talking about. So here, not much difference. The code is more or less the same. Excuse me. When you do this, this is what you get. All right, the topics have, first topic is drive, game, card, problem, thanks, disk, port, controller, work. The second has card, video, driver, surrender, skepticism, chastity, shamefulness. So I'll let you decide. The third is Israel, food, delete, prize, Jewish, South. This clearly seems to be moon. It clearly seems to be about geopolitical situation. So that's that. And this seems to be about sports, bike, ride, motorcycle, rear, car. But there's a bit of morality thrown in. Auto, rider, captain. Would you all agree that this looks like sports? Isn't it? Car in sports. We don't have a category for sports. We have put it in the car. Bike, right? Bike, rider. So topic 3 seems pretty clean. Yeah. And we will see in a visualization if that is true. Topic 4 is no people think like God want, and we'll see. Topic 5 is Korish, Armenish, plain, antenna, liar, and so forth. So let's see. There is a measure. There are 2 measures actually. One is perplexity measure. You can measure how well the topics are separated out. And that measure is called the perplexity measure. You can see a value of -10, so value, but I want you to read up on this. The other thing is there's another measure which I leave as homework for you, if you guys can take it down. It's called the coherence score. So just like I did the perplexity measure, I want you to, as a homework, add, right in this analysis, in this notebook, add coherence score, right? Coherence score model to this. So now let's visualize this topics, how well it has separated. Remember 6 topics. So this is a visualization. So I'll just make the thing a little bit smaller. Okay. Yes. So when you look at this, you see, what do you see? Topic 1 seems to be really separated out. You know, the more the separation between the topics, the better. So clearly topic 1 is dominant and it seems to be well separated out.
Can you explain the axis here?
Yes. So this is the principal components, principal component, first 2 principal components of the topics itself. Right? You further take the topics and reduce it to 2 dimensions so that you can represent it in a plane. In those 2 dimensions, clearly the first topic, and these are called principal components. So let's take it as a Premjit. PCA takes a bit of time to explain, so I won't go into full detail, but here's a simplified view. If you were to take data and you would to project it down in the most meaningful way possible to 2 dimensions so that you can visualize it, right? In a linear and it's some sense a linear projection downwards. PCA is the classic technique to do that. Right?
But in terms of those, when we saw those coefficients right now, they were totally about what, 6 or 7 variables, right?
Those were the word variables. Yes, yeah. Those were about the words.
So in this visualization, it's actually condensing that from, I think there were about 8 variables there.
No. You had 6 topics. You had 6 topics, right? So you have a 6th. Yeah, you're taking that. Yes. So all of those variables. What you're doing is you're projecting all those topics down to a 2-dimensional plane. Right. So all the documents that are in the out there, and basically the topics, you're putting it down in a two-dimensional plane here. You're saying, how do I put, if I were to project all the topics down to two dimensions, yes, okay, take your word space, but project it down to two dimensions. What would it look like?
Okay.
Right? But so the more the separation, the better. So we clearly see that this is far, this is far, but these guys are all pretty close to each other. So let's look at it a little bit in detail. Topic 1, no people like God. See, God is an expression that people use in computers, in science, everywhere. People will keep saying, oh God, right? Or oh my God, and so on and so forth. So I wouldn't pay too much attention to that, but look at the rest of it. Belief, come, system, work, year, point, car. Do you see a clear topic here? I'll leave that for you to sit and judge. The next is this one, drive. This one I would say is very clear. It's about computers. Look at the words: drive, game, card, problem, driver, controller, modem, motherboard. Would you say that it has separated out this one well, guys? Right. And then let's look at this guy. This also seems to be, interestingly, it seems to have mixed computers. A lot, the lower half of the words are computer words, and somehow it has thrown in skepticism, chastity, shameful, which are religion related topics, intellect, into this. So not good. This is clearly about sports. Topic 3 seems pretty clear. It's about sports: bike, ride, motorcycle, car, auto, rider, captain, wheel. What about number 6? It seems to have some degree of overlap, but to me, it looked like a fairly separated out topic, though I couldn't make out what topic it is. It seems to be about geopolitics, location based or something like that. But it has science in it, Mars, Venus, space basically in it. And then the 5th one is much more a mixture of space and politics, the countries, Israel, Palestine, Turkey, and so forth, Jewish, and so forth. It seems to have mixed up politics with some amount of science to it. So this is how Gensim worked. There is another library, Mallet, which is a Java-based library, which is very effective, actually. In my view, quite often it gives you superior results. By the way, when I'm doing all this here, guys, I have not done any kind of tuning or optimization. In all exercises of NLP, you gain a lot by properly tuning your models, playing around, doing things, and you spend a lot of time doing that. Right? And so what I would encourage you to do is as you work with the lab, try to improve it. So here is a hint. I've deliberately left a lot of basic optimizations I have not done because it would have complicated the code and made it hard to read. So I've not done those things. Play with those. For the very basic, you can play with just 3 topics and see how well separated they are. Then you can go around and play with whether lemmatization was a good idea or not. Right? The other most important thing that I forgot, or not forgot, I deliberately didn't do it, is something called bigrams and trigrams. I hadn't taught you that. It is basically putting 2 adjacent words together into a pair as a single unit. It's called a bigram. So happy cow, right? The 2 words. I saw a happy cow. So I saw would become a bigram, saw a would become a bigram, and happy, a happy would become a bigram, and happy cow would become a bigram. If you remove the stop words, then it would become saw, right? Happy cow. So the bigrams would be saw happy, right? Happy cow, and so forth. So, and as you can imagine that those add meaning. So please take this as a homework. I happen to know that for this particular analysis, when you add bigrams and trigrams, those are expensive to add, by the way. It will explode your vocabulary. So start with just bigrams. See how much your results improve if you add bigrams to this analysis.
So Asif, what is the intuition for engrams helping in topic modeling?
Yeah, so think of it. When you use words, sometimes the words don't convey the meaning. For example, the word machine learning together. Machine will convey a sense, it will contribute a sort of topics or contribute a lot to mechanical engineering. Learning will contribute a lot to education.
Okay.
But when you machine learning together, you realize that as a pair, they contribute a lot to artificial intelligence.
Okay.
The word artificial intelligence itself. Do you see why bigrams are useful and worth adding to the vocabulary?
Okay. Yep.
So please do add bigrams to the vocabulary. The hint is it's just a few lines of code. Enhance this and see how well your topic modeling works when you add bigrams to this exercise. Right. All right, guys. So now I'm using mallet. Using mallet. Now, good thing is that, do you notice that you didn't have to write Java code? You just literally stayed within Gensim, used mallet as a wrapper. It gives you a wrapper, Gensim wrapper for mallet. So you can use mallet for, again, a latent Dirichlet allocation. It's a twist on that. And then let's see how well it performs. Do you feel that the topics are separated out, guys, this time? The bubbles are separated out?
Yes.
Yeah.
It is separated out, right? It's better separated. It's just a general experience, by the way. In general, I find a mallet superior. And then whether or not it has done a good job, actually, I'll give you a hint, guys. Add the bigrams, then your results will significantly improve. But for what it is worth, as a quick and dirty, I brought it here. You can decide what it is about, these topics about. They seem to be fairly clean, right? This seems to be about mechanical, about cars, sports, so forth. God knows what this is about. If you remove two-door and bumper and body, well, it seems to be rather mixed. This one seems to be pretty pure. Anaheim, Brent, Satan, problem, system, I can't make out. But anyway, that is that. But at this moment, without adding bigrams, this is how it looks. So add bigrams, guys. Now, there is one thing I wanted to bring in at some point. It has not anything to do with topic modeling, actually. It is independent of that. See, Python code, when you run, it runs in a single thread, in the sense that it is a sequential run, all that code. When you work with large data frames, things can get pretty slow, because suppose your machine these days has many cores. For example, my workstation has 64 cores. If you have Threadripper, it will have 32 physical cores, means 64 sort of a hyperthreading, or sort of like that, virtual cores or something. Let's say that it has 32 or 64. What will happen is, normally when you run your code, only one core is in effect. So your performance is 1/64th, or if you have more cores, 1/100th or something. So how do you speed things up? So Python has this very nice library called joblib, right? If you can make your problem, in some sense, parallelizable. So for example, if you're doing an operation to each element in a list, and that it doesn't have to deal with, there is no interdependence between them. Every word, let's say that you're capitalizing every word or breaking every word into NLP tokens, right? Tokenizing the words. You realize that you can deal with every text separately, every email separately. No reason to do them sequentially. So the point that and so to illustrate that point, I put this code here, and hopefully this is your starting point for um, doing parallel computing in Python. So you notice the code is straightforward. You create a parallel object, and you then give it a function. You give it an argument. What will be the argument to the function? And then from each text from a list of texts, which is news groups. Remember the text column had 11,000 such records. So it will execute faster, right? And you'll get the same result. So this is about job parallelization, not necessarily about topic modeling, but you can and should use it for this purpose. Like you should use it everywhere that you can. Okay? So, all right, guys. So one of you requested that in 1 hour, I should give an overview of what I'm going to teach in the remaining time. And so we are done with the overview. Any questions before I go through this a bit more slowly?
Asif,
Uh-huh.
so what are some examples that this could be valuable? So one thing is, let's say I'm trying to figure out a topic. To look at, as example, I look at the app called Flip, which gives me the news. I could choose data science, politics, anything, right? And on those articles from newspaper, and then it gets summarized for me. Okay, that will show. So I'm trying to figure out, like when I do this modeling in the practical corporate world, what are the use cases you have in mind that could be that we could use it?
Let me see that. See, first of all, before I answer your question, let me put one caveat. See, guys, do you notice that if you just run through the analysis in a simple way, direct way, your topics are not terribly good, right? They're good enough. That's all you can say, but they're not terribly good. There is a huge scope of improvement of tuning this. And so people who do topic modeling, they often spend a lot of time tuning with this, playing with the number of topics, seeing how it matches, adding bigrams and trigrams, checking, playing with different parameters, the hyperparameter tuning. Machine learning, the difference is quite high in performance between a straightforward code and an optimized code. Obviously, optimized code means now the code looks more complex, right? Or there is more going on in the code. So when you're just learning, you don't do that. Learn to do the straightforward way as here, and then do a better job of tuning it and making it better. Having said that, to your question, so there are many examples. Like for example, you're getting a lot of Jira tickets, Shani, from your customers. A lot of issues or complaints and suggestions and feedback are coming to you.
Mm-hmm.
You don't know what those things are about. They're just plain running texts. Like suppose you sit on a division. Let's say that you sit on the WebEx division, right? Besides the fact that they're all about WebEx, it's the feedback that you're getting or the reports that you're getting could be free-flowing text, and you don't really know what the topics are, isn't it? So what can you do? You can take all the text and do so topic modeling is unsupervised. You can see what topics they seem to be about by doing topic modeling, by looking at the coherence score or the perplexity metric, and trying to come out with clean set of topics. First, you have to find how many topics it sort of decomposes into, you visualize, you do all sorts of things, and then finally you gravitate to a stable point. You converge. Once you have converged, now you look at the topics and you try to give it an interpretation. For example, one topic I hope is that WebEx does a terrible job in allowing you to add a lot of virtual backgrounds. Now, for example, they have given that feature. But if I were to guess, with Zoom giving that feature, a lot of people must have given that feedback. We want it here too.
Yep.
right? Or basic direct integration to YouTube. It doesn't have it. So I'm sure there would be, I mean, I'm just giving the points that that helped, made me move after so many years of using WebEx, made me move to Zoom. So if you go and look at the feedback, you'll find something. But how do you find those? How do you find the core themes in the feedback? That is one. Look at the ticketing system. When you do a topic modeling on the ticketing system, you may realize that a lot of people are talking about certain themes or topics which don't fall into your traditional buckets of this product, this component. You see that, right? And so on and so forth. You can use it. Suppose you see a lot of news articles emerging. You can quickly do a topic analysis and find the most representative document or sentence around that topic and see what is it. It could give you an idea of the emerging news, right? So it has a wide application. Topic modeling is a big deal, right? Now, these are the examples that I just thought of the top of my head. But if you spend a bit more time, then more and more examples will come to you.
Got it.
Asif, I have a design question here. So right now, when we did this exercise, what it's essentially done is for each of those topics, they were essentially a combination of words, right? That's how it basically defined topics. We have 6 topics. Each of them were a combination of 8 or 9 words.
No. You don't think of it like that. See, looking at the lab, you may think it is like that. What that topic is showing you is that how much weightage it is giving to some of the more important words for that topic.
Yeah, I was building on that, Asif. So yeah. So right now it's done it on words, but I was wondering, is there a way to define these in such a way that it becomes a 2-level process? What I'm looking for is, let's say these words, some of these words were essentially things that, let's say, describe technology. Some of these words are things that talk about emotions. So I want a 2-level.
Yes, you could do that. See, your problem, for example, right? You could do something like that. See, this is where the okay. See, there's supervised learning and unsupervised learning. If you have some label data for this system to learn that this is about emotions and this is about technology, then in the first stage, you could just run a classifier. And in the second phase, then having classified the data, within technology, you can find topics, and within emotional stuff, you can find topics. Or you could try your luck by just doing topic modeling into 2 topics and hope that a good topic modeling result would be that everything to do with technology falls in one topic and everything to do with emotions and experiences falls into other topic. So you have to play with it and see.
Okay.
Right? A lot of this is experimentation. Another way that I would see is, do you notice that when I did a classifier, the classifier had a very high degree of accuracy, 83% accuracy. Supervised learning. But this topic modeling is unsupervised learning, and then the results are more mixed. You have to work a lot harder for it to give you good clarity. This is a general experience you have. See, the reason supervised learning, you tend to get higher accuracy or quicker results is because the hard work has already been done in giving you the data. Creating labeled data is extremely hard and extremely expensive, right? Except in such situations like this, where you already know, you're going to news groups and harvesting the text, in which case you know what the news group is, right? Or let us say that you're looking, suppose you want 4 subjects and you want to gather, from the web some content around the 4 subjects. If you specifically know this subject, you're searching for the web and putting it in a directory, all those content locally in a directory marked science, right? You already know, you have labeled data. That is a gold standard. But now, remember that used human effort, right? Increasingly, the big push in machine learning is how can we do things either in a semi-supervised or an unsupervised manner? Because supervised doesn't scale very well, right? In many situations, in some situations, it's cheap to get labeled data. In most situations, it's very expensive to get labeled data. Most of the data comes unlabeled in real life. So that is why the importance of techniques like topic modeling, because they help you in that, or clustering and dimensionality reduction and so on and so forth, right? They have tremendous importance, because if you can just sit here and keep on refining your mathematics, and you can therefore discover very good themes, what you have just saved yourself is a massive spending on people sitting and labeling data.
Okay.
So that's the practical aspect of it. Any other questions, guys?
Asif,
Yes.
it's just some feedback. I like this format better than the old one. I'm not sure how other people feel.
Okay, a quick walk through the whole thing in an hour. Excellent. So I'll follow this this process, guys. Any other feedback, guys? Otherwise, we'll declare it a break. Let's meet after dinner, and then we'll go over this code a little bit more in detail. This code is actually quite simple. There isn't much more detail to go after, but I'll still go over it line by line in the next. And so those of you who understand this code, you all have downloaded it. If you understand this code, then you don't need to come for the second half. But if you do need some help with that, then do please come back and we'll go over the code in detail. It is 8:23 on my clock. I will stop the recording. So this should be easy for you. The first, you just listen to the recording, the video. Now every session I'll break it up into two videos, part 1 and part 2. Part 1 would cover the whole thing, and part 2 will go into details and clarifications. All right, guys. So let's take a break. It's 8:23. Should we give ourselves 25, 40, 50, 8:50? Should we regroup at 8:50? Is this reasonable in 25 minutes? Or maybe we can group earlier, 8:45, 20 minutes. Is 20 minutes okay, guys? Or should we take a little longer?
This is fine. 20 minutes is fine.
It's fine, right? Okay.
Yeah, we can get back at 8:45.
Yeah, let's see. So I'll see you guys at 8:45. By the way, Shankar, do you have any further suggestions on topic modeling since you're doing it on a day-to-day basis? What else should I include?
I think I used it in a previous project. Right now, at least at my present job, people are using topic modeling, but then at least these things, at least we have a good understanding of what the topics are. Generally in data that are not clean, the topic modeling is not that useful.
It's not that
That's
useful.
what you have found out.
Yes, yes. It's pretty hard to get it right.
Yeah.
You have to do a lot of hard work on it. Yes.
And then the only way you can adjust is the coherence score and
Coherence score, exactly, and use that to.
And then sometimes what happens is it is not just the data. Your data becomes too domain specific, so that topics do not match to your expectations, or all the things come in one topic.
Yeah.
Most of the things. So that is the limitations we faced.
Yeah, that's right. No, so my question is, you see, I walked through the notebook.
Yeah, this is a good approach. Yeah.
I skipped the bigram, which is the homework for you guys, bigram track, because those make a huge difference in my experience. Right? Yeah, so exactly. Grams make a huge experience. Then anything else big that I missed?
I think you covered Malik. I think probably this is whatever you can do with topic modeling. You've covered most of this.
Pretty much at the limit.
I think this is the high end. like the maximum you can do with this.
Maximum you can do with it, yeah. There is one particular algorithm I didn't do. It is a HDA, hierarchical LDA.
Oh,
Right? The reason I didn't do is because I've never found it to outperform Mallet. Actually, Mallet also has an implementation for it. People say it's supposed to outperform LDA. It's supposed to be a better version of it. I don't know. In my experience, I've never found it better. Have you had a different experience with it?
no. I have never used XDA. Mostly, I used LDA for most of my work.
Nice. I think we are together. But yeah, so that is one thing I haven't covered. Maybe for next time. All right, guys. I'll see you at 8:45.
Okay, thank you.
Are we all back? Oh, 19. There are some people have dropped off. Let's give them a couple of minutes for them to show up. Did you guys finish your dinner?
Yes.
Uh, just wait a minute or two for the attendance to reach 20 and then we'll start. By the way, I forgot whether Kate managed to join the group or not. Did she make her way into the Zoom? Raji, would you know?
Sorry, Asif, what?
Did Kate manage to join the Zoom?
Yes, she liked like the one where it was like it was told to her that the YouTube channel is live. So I suppose she is watching on from YouTube. You want me to confirm once with her?
Yes.
She's watching from YouTube.
From YouTube. Okay.
Yeah.
All right, guys, I'm about to start. I don't see more people coming. So this is the second part of our lab on topic modeling. In the first part, we did a quick scan through the solution and we talked about the high-level issues. Now, what I want to do is be very clear about the homework, guys. One important homework is play with changing the number of topics, right? Play with changing the number of, the bigrams, trigrams, and so forth. These two are essential. Make sure we do that. And those are two. I didn't do a particular form of LDA, latent dirichlet allocation called excuse me, HDA. I will release code samples for that. There's nothing unusual about it. It's just a couple of lines. But you can play with that. Now, if you look at the way I have changed the code, there is an opportunity to play with this in slightly different ways. I would like to show you my code and explain what I mean. See, you have space, pronunciation, pronouns, punctuation, symbols, unknown. I have deliberately marked it with a hash, right? So that you can uncomment it and see what effect it will have on your overall results, right? Things that you remove and keep. Then change this. For example, I'm throwing away words or after lemmatization whose size is just one, a single letter, and so on and so forth. So it is at 2. What if you change it to like 4 or you do something? What if you throw away numbers, right? Things like that. So play with this file, clean text, see what happens. And you'll find that you'll see some subtle small differences in what you are doing, right? And here also you can sort of, so that is one thing worth doing. So now going through this lab, what I would like to do is just go over each of these and see if there are any questions and explain it a little bit more in detail. If we can get through that part quicker, then I would like to give the last 40 minutes or 45 minutes to explaining or making progress with our project and giving you guys some suggestion for the projects, because I believe at this moment you guys haven't made any large progress with it so far. So let's go with that. So the imports, by now you must have, is this looking anything unusual in the imports, guys? Anybody notices anything unusual?
What is this multinomial NB?
A little bit louder, please.
The import of multinomial NB.
Where is multinomial?
Line 25.
Oh, multinomial naive bias. It is a very simple naive. It is the naive bias classifier for this thing data.
Where are we using that?
Oh, so remember this I don't use for topic modeling, but I said that just to see how topic modeling is and whether the ground truth of the data is that the topics are well separated. Remember we made a classifier here, a basic classifier.
Okay.
Let's go here. See, I created a very basic classifier. What does a classifier do? See, I could have used something else. I could have used logistic regression or random forest or decision tree or whatever. The reason I use multinomial naive bias is because it's very fast. Do you notice that it is a cheap model? The model finished building in just 37 milliseconds. Right? So I wanted to just use it for basic classification to get a sense if the topics are well separated out in reality, whether the ground truth topics are well separated out. And it seems to be, with 83% F1 score, which is quite good, topics do seem well separated out.
Yes.
We got that, right? Okay, so let's get back to imports. By the way, no particular reason. If you don't like multinomial, just use logistic regression, use whatever that you feel comfortable with. It doesn't matter. Okay, anything else, guys?
So what is bunch in line 23?
Very good question. So what happens is when you use the scikit-learn's dataset, the datasets library coming from somewhere here, I have scikit-learn dataset.
Line 22.
Line 22, exactly. So this function, what it returns is, it returns an object whose member variables are, actually, why am I just saying that? Let me just go to that. sklearn bunch. Let us do that. sklearn bunch. So you look at this bunch, what it contains is other version, utils bunch. It just contains, it's basically a hash map. More realistically speaking, actually this documentation is terrible. So let me explain it here. It's a hash map which contains the data, the text. It contains the target variable. What is the target? This. Do you see that? Right. It also contains some explanations and basic things, some text and so forth, metadata. That's it. So think of it as just a hash map where the data and the labels are kept as key value. Text and labels are kept as key value. All right.
What are the labels? 1, 2, 3, 4. Is that the label?
No. That is something I just created. 20 news groups, right? Labels are the name of the news group.
Oh, I see. And then what's the tag?
Taken.
Then what is the target variable? What's the difference between label and target variable?
It is the target variable. The words are interchangeable.
Oh, okay.
When people use the word label, target variable, output, these are all interchangeable words. Think of it as target. Actually, they use the word target. This in the bunch, no? All of these values are kept there. So do you see bunch.target names will tell you all the target names, the unique values of the target.
So bunch is a hash map of what?
It is a hash map which contains the text. There is one list of text, which is the data. The key is the data and the value is a list of all the English, email content.
Okay.
And then there is another key, which is called target, whose value is for each of the email, which news group it came from.
Okay.
Are we getting it? So guys, do you know what a news group is? Or maybe you guys are too young at this. You don't know the world of news groups. News groups are like Google groups or Yahoo groups. The word news group, right? It harks back to 20, 25 years ago, where most of us used to subscribe to news groups and we used to keep getting messages and posting messages on news group.
Alt.news. Blah, blah,
Yes,
blah.
exactly. So the thing is, these are all news groups, and the equivalent today is the Google group or Yahoo group or whatever it is, or maybe your WhatsApp channels, your WhatsApp. They are like that. So what happens? People post messages there, right? And messages are on certain themes. Or think of it as a Slack channel. You have a channel for ML400, you have a channel for different topics. So 20 years ago, the equivalent of these things used to be on the Linux machines, on the Unix machines, there used to be this news group, a news server. And you could subscribe to these news groups.
The protocol, right? NNTP.
Yes, exactly. You remember that phrase. Yeah, you're from that generation. And I mean, even today you can install, and I hope it's free. You don't have to go and use all this fancy stuff. So that is it. Does that explain to you, Nisak, for you?
Yeah, so it has target label, and what's the other target? So one is like the document itself.
See,
Then a news group, and then
let us do this. Let us go here and look at the documentation, and I'll show it to you what the member variables are.
So Nisarg, it's just a directory structure in which people organize documents.
Yeah. So when you look at the returns and okay, a bunch, it is a dictionary. So look at this. A bunch is a dictionary-like object with the following attributes. One key is called data. What is it? It's a list of texts. Part looks easy.
Yeah.
And each text comes from a news group.
Yeah.
Now, where is the news group stored? Target. Do you see target?
Okay.
It is a list of labels, target labels, news group names.
Okay.
Right. Then file names is not very relevant. It just tells you when you download this data, where on your machine it sits. Right. And it will sit in your home directory under something called sklearn data. You can go and check it out. There is another field called description. It will give you the description of the data set. Now there is another field called target names, right? It is the list of the target. Now target names is nothing but the unique values, distinct values of the target list.
I see.
It is nothing but calling distinct or unique on this list. If you call unique on it, you'll still get the same thing.
I see.
Easy enough?
Yeah.
That is it. So that's how we understand that. So I'm just printing out the target names, that is that, and then just do a count plot. Basic. Do I hear a question from somebody?
Hi, Asif. This is Sudhir. I just wanted to check with you about that. We have the 20 some. 1 second. That fetch 20 news group, right? So is that a function or how? I didn't quite get that.
This comes built in with the scikit-learn. If you call this function, see, they give you, the scikit-learn comes with some standard data sets because the 20 news group is a very, it's like, do you remember the breast cancer data set or the California housing data sets?
Yes.
Right. So what happens is all the famous data sets that we use for learning, scikit actually makes it very convenient to. It has the scikit data set, right?
Okay.
Which has a list of all the famous data sets. That's all.
Got it. Got it. Okay, fine. Sounds good. Yeah. Thank you, Asif.
That is it. There's nothing else to that. Data sets. Here we go. Yeah. Data sets and the scikit data sets loading utilities. So do you see load diabetes data set, load iris? We remember doing the iris data set, the wine data set, the California housing data set, and the 20 newsgroup data sets. So all of these are just famous data sets and you just use it.
Yeah, sure. Thank you, Asif.
Asif, one question. This in line 7, you also have targets, and then you mentioned dictionary. So what kind of like, what is this code type? Like, how have you written this? I've never seen that before. Like targets, and then you have
line number.
Line number 7, and then you mentioned dictionaries separately.
Okay. See, what happens is most people, they would. Okay, are you familiar with an empty dictionary like this? Somebody creating.
I understand empty dictionary, but why do you like? What is this way of? Is that a way of naming the dictionary? Targets.
Yeah, targets is the name, right? So here's the deal. You would see people in Python doing just like this.
Exactly.
I tend to be more clear. I tend to tell what type it is. So that later on when you're reading the code, people never get confused that it's a dictionary or what is it.
Okay.
I'm just being explicit. Do you notice that I'm being explicit here also? There is no reason to do this. Specify the type, right? But I could have just said bunch is equal to fetch this. But I wanted you guys to know what kind of object bunch is, that it's an instance of the bunch class. And that's why I did that. See, it's called type hinting in Python. When you do type hinting in Python, there are two benefits. First, you make it much more easy for a reader to know what your code does, right? What those variables are. And secondly, if you're using a tool like PyCharm or any IDE, then when you do type hinting, in return, the code completions and code assists becomes much more powerful. It begins to resemble a little bit like the power that you get with Java or any of the typed languages. Right? When you write it in an editor, code editor, you will see how much power comes. So type hinting is, I would strongly suggest that people do it. In Python, it is optional, but your code will be a lot cleaner if you do type hinting. Is any one of you familiar with type hinting or doing type hinting in your workplace? Anybody here? Nobody. Huh? Oh, interesting. So you guys write Python code without type hinting.
Asif, actually, I learned type hinting, when you were helping us with the Python class. So, which I found it really helpful. Sometimes, when even in 100 data set, right? When we were working on, we used to get confused where, the explicit typecasting we should have done, but we would have missed all those things.
Right.
So this really is helpful.
Yes. Yeah. Thanks for saying that. So, all right, guys. So this is a simple count plot, isn't it? No particular reason I used Seaborn. Seaborn just makes it prettier. You could have used matplotlib.bar. No, bar plot.
So what is it counting here, Asif?
Counts how many records belong to each of the target types, to each of the news groups.
I see. So it just takes a length of the target group. So
No. So how many, see in this row data, no? In the data that you have, how many rows belong to, how many items of data belong, how many
I see.
emails belong to alt atheism. So it seems to be about 490 emails seems to belong to alt atheism. You see that, right?
I see.
Other ones seem to have a little less than 600.
Target will be the news groups, right? It won't be the target names.
Yes, targets are the news groups. So these emails belong to those news groups, right? It is just showing you the distribution of emails across the news groups.
Right, but in this case, like one won't be atheism, right? It will be some news group.
Look it up. Here, look at the table here. One is atheism.
No, but that isn't that target name. So I thought target name was the label and target was the news group.
No. Oh goodness. See, target, they call the variable. All I'm doing is all the target values in the group, which news group they belong to. So I'm grouping all the emails by the news groups they belong to. As simple as that.
Okay.
Are we getting that?
Yeah, because you use target names up there and you're using target
It's just
here.
a variable, no? It's just a target names is the distinct value of targets. The target in the bunch. In the bunch, look here. Well, okay. Basically, right, target names will have, it is just a unique list of all the possible target values.
Okay.
The variable name is target. These are all the values that target can take.
Okay.
The y variable, if you think in terms of x and y is target. These are all the distinct values that target can take. Now the question is, how many rows of data has this particular value of the target, right? It turns out that there are about 490 such rows, right? And so forth. That is it. So 490 emails seems to belong to that group. Now, is it more clear?
Yeah, but more clear.
So, see if I have one quick question. So, this entire thing target dot not like if you scroll up a little bit. So, this entire thing talk dot politics dot medis. This entire name is the target name, right? This is the
Yes,
news group
one
name.
news group name. It is the name of one news group.
Okay.
Right? So let me make it very real for you. Let me take one of these comp.mac.software hardware. Let's go search. Somebody may have an archive of these almost surely. Let me go here and see hardware. Yes, comp. Do you notice that here is a web archive? Somebody has that archive of this. Do you see? What do you see? This is a message board, no? Where people have messages. Do you notice that there are emails and conversations back and forth, and people are discussing things?
Yes.
As simple as that. So the name of this mailing, what in modern world you call discussion groups or discussion boards or whatever it is, the word, or Yahoo groups or whatever you call it. The name of this is comp.sys.mac.hardware, right? Which is what you see here. You can take any other one of them. For example, let's take sock.religion.christian. See if there is such a thing in the world. Name that. Oh, here we go. So, well, you notice that they are somewhere or the other, somebody would have archived this. Sock.religion, yeah, here it is. Once again, people are talking about conscious intent. You see that? They're talking about this religious concepts, I think. I don't know why physics has come in here, but okay. So are you guys understanding what a news group is? Aditya, is it clear now?
Yes, yes.
So it is as simple as that. These are the names of the news groups, and each record is an email or a message in that news group. Somebody posted in the news group. That's all. Look at the data. When you look at the data, you'll see it, right? Do you see this data? No, one data says, I was wondering if anyone out there could enlighten me on this car I saw the other day. It was a two-door sports car, etc., right? And it belongs to the rec.auto target group, right? Then there is something called a fair number of brave souls, blah. It belongs to this. Mac hardware. Do you see this? Is it now becoming a bit more clear what the concept of this newsgroup data is?
Yes.
That's all, it's just a message in a newsgroup. And how many such messages are there? 11,314. And so what I'm doing is I'm merging some of the records, and you can create your own grouping. You can play the games and group it together. Then lastly, what I do is I create a new column called topic. I leave the target column there. I create lesser number of topics. So how many topics do you see? Politics, religion, sports, computer, science, for sale. 6 topics, right? You create your own number of topics. If you want, you can keep all 20 topics. See how well it works, right? Then what do I do here? So is this code clear, guys? What am I doing? I'm adding one more column to this pandas data frame called topic, right? Where I'm creating these topics to be based on our own choices. Right? We are saying that don't give it this name com, sys, mac, blah. Just call it computer. Right? Com graphics is also about computer. Am I making sense, guys, or is it all looking very obscure? Anyone?
Yeah, it makes sense.
Makes sense now, right? Okay, this is it. Then
it's like Craigslist also, right? In a way.
Exactly. It is like Craigslist, except that Craigslist, of course, it is about advertisements, but something similar. It's very similar to that.
Yes.
I guess you guys are the young generation. You haven't seen the old news scripts. We used to live off that. For most of our things, if we wanted to get information, before all these powerful search engines came about, newsgroups were the way. So stop words. Let's look at this element. What are stop words? Do we all understand? Anyone who wants me to explain that? Stop words. Sorry. Right. Let's say do you see what the stop words are? I just ran this code. What are these stop words? Just looking at it, can somebody explain to me what these stop words are? What are they?
Common words.
Yeah, common words that don't add much meaning. They are the glue words, that help make sentences, right? That help explain or the structure of the sentence conveys meaning, but it is not theme. It doesn't convey the theme of the sentence in any way. So those are the stop words, right? Then I'll remove this from my thing. So we need to clean this text. So this is a thing about how do we clean this text. And I showed you the utility. What I'm doing is for every token, what is a token? We talked about tokens. So this is a couple of sentences, isn't it? So in this sentence, when we have a text, what does the word token mean? Tokens are things that you create out of by understanding the text word by word. Roughly speaking, one token could be one word or one punctuation. Do you get that? Right? So for example, this full stop is a token, this word is a token, all of these are tokens. So think of them as words and punctuations are tokens, right? So it will have a lot of tokens. Now, these tokens, some you want to keep, some you don't want to keep. You want to not keep the URLs, you don't want to keep email addresses and so forth. Are we together, guys? Does that make sense? Right? If I want to clean out this text, would you agree that this is much better when it comes to the actual semantic content of this text? This is it is better to just take these words out. So far, so good, guys? So that is it.
One little comment here. I mean, I don't know if we can solve it here. So I've been following the lesson together by running the lab, but every time I go through this clean text, my Python notebook seems to get corrupted. So I have to figure that out. But I was wondering do you have any insight in terms of what's happening inside clean text, which could be peculiar based on implementation?
Not at all. I have never experienced that. Clean text is just a very tiny function. Just this. Yeah.
Okay.
Check if the word is worth keeping, and then you use it. So if you are having a problem, let me know if anybody else is having a problem. See, guys, I do understand that there are problems. For example, yesterday we are struggling with another person, Shini, his laptop, and so forth. So I have a bit of a handicap. I only work on Linux, and I use Windows only when I'm teaching. Like, for example, now, I'm not terribly familiar with Windows, but familiar enough. I don't know Mac. I'm guessing, Premjit, you have a Mac.
Yeah, I'm on a Mac, yeah.
Yeah, so Mac is my handicap. Never used it. In my life, I never moved away from Unix/Linux. I worked on all my life on either VAX clusters, which most of you don't know about, or Unix machines. So my day-to-day is on Unix. And when you do much of this machine learning on a Linux machine, the Ubuntu, for example, is a de facto standard. Almost everything works flawlessly on Ubuntu. So when I hear all of these issues happening, sometimes I'm able to debug and find what's happening on other people's machines. Sometimes I'm not able to, right? So I just help say that, take this Docker container here, everything is properly set up, and just fire this up.
Yeah, I'll figure this out, Asif, and I'll post it on our group. Or if I don't, Prachi might figure it out.
So all of you Mac people, the Mac fans or Apple fans, you guys need to club together and help each other out and take Prachi's help. But I can't imagine why something simple like this should bail out on you. So, all right. So we clean this text, and as you notice that this text here looks a lot cleaner than what was there before, isn't it? Look at the text here from article blah, 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 and look at the content here. I hope you would agree that this looks a lot cleaner. Guys?
Yes.
Asif, would the list of lists ever create any issues later on, or do we need to keep that in mind always while processing the data downstream?
No. See, I created into a pandas data frame now. No? Do you see this lovely pandas data frame?
Mhm.
Right? Do you notice that I converted news groups, news apply? This news groups was a data frame. Where did I create the data frame? Here, a little bit up. Do you see me create a data frame?
Yeah.
So once it is data frames, now we are not still having it like that, but we will create list of lists where needed. But list of lists is very straightforward in pandas. I mean, Python is commonly used.
No, but you use list of list up there, right? Just one line above.
Where?
In news groups, then you use, basically it's clean text and topic in line 11. So
No,
that is the list of list, right?
no. It is a pandas syntax. You are saying that from the newsgroup pandas, create another data frame keeping only these two columns. It's not a list of lists.
But then why wouldn't you just keep clean text and topic instead of keeping it under a list?
Up into two parts so that the meaning is clear. Columns to keep is equal to. Let me do that and see if this makes you, if it makes it easier for you to understand. Columns.
No, I understand that, but what I'm saying is why keep clean text and topic in a list? Why not just keep them within, say, you have news groups, pandas?
Yeah, just for cleanliness, no particular reason. I just wanted to keep a smaller data frame in which I have only the things I need.
No, but if you just had clean text, comma, topic without the two brackets, it won't work, right?
Oh, it won't work. It is just
And that is because it's a list, right?
Yeah. So pandas says that when you project, when you create another data frame with a limited columns, you must give the columns as a list, and the symbol of list is that square bracket.
I see. I thought the reason we are using list is clean text generates a list.
No. It's not that. It's just a column name.
Okay.
So this is basic pandas syntax.
Okay.
So that is that. So now you have a simple data frame with only two columns, right? Now we go through, and how do I know how many rows there are? You can just call the length on it. Then it has 11,314 rows in the clean text. Again, we haven't lost any rows or something. Next is so if we write a simple, so first thing we do is you can't do anything with text. Remember, we need to convert text into a vector space representation. So in this line, we are just vectorizing the text. Which column? This column, right? The clean text column. It needs to be vectorized. Right? Do we remember that, guys, from last time I said that words needs, sentences and documents, they need a vector space representation because machine learning only works with vector spaces. It is a mathematics on vector spaces. It's basically linear algebra, right? A lot of linear algebra. You need to represent it in a vector space. Everything. You might have a sentence, but the sentence must look like a vector. Some vector in a Euclidean space. So guys, tell me if I need to explain that concept over again. That is clear, isn't it? Nisarg?
What is data.assign?
Oh, it is just a way of creating a new column.
Okay, and that's what I thought.
Right.
So, as if I was just looking at the TF-ID of the numbers, they don't look like it's like one vector. There's 0 and then some number.
The notation is strange. Ignore the notation. Huh?
Oh, okay.
Yeah. So the notation, the way it is done is strange. Don't worry about it, but in your mind, think of it as the vectors the way I taught you. Right? So basically what it means is this particular word whose sort of a name is this peculiar thing, it has this much
Oh, I see.
Value, right? So remember, it was sort of each word's TF-IDF value is this. That's all. Right? And when you do the TF-IDF,
But
remember
it
it
seems
is
like
with
the
respect to the
same.
document.
It
So
seems like the same word is there for all of them. Maybe because it's sorted, is it?
yeah, it is just sorted. That's all. So ignore this part. At this moment, this thing that is here, don't pay too much attention to that. So this is it. By the way, this is just a little syntax to put so many columns, so many rows. So one of the things is it is 150 here, and this is it, right? So you represent it. So this part is clear now, right? This, by the way, is a standard. So besides the TF-IDF, which is a vectorizer to create vectors out of what? The clean text column. Each of these converted into a vector, TF-IDF vector. So now you are in a lovely space. You have the vectors, and therefore you can do machine learning. Remember our standard machine learning, the X is the input, little y is the output. Output, we know what it is. It is the topic. And the input now are the vectors, doc vectors. A document, like a text document being one email, has been converted into a vector. Now what I'm doing is I'm doing a split between test train. There are 11,000 rows, so I approximately, give or take. And so I'm taking the first 7,000 to train, and the remaining 4,000 odd to test. This is a test train split. Is this simple, guys? This is basic array, the list notation, the indexing notation of Python.
What was data.topic?
Remember, look at the data. This is your data frame, right? What is
okay, just
column here? This is really your Y, right? This is your target variable, isn't it? In a classifier, if you're doing a classifier, this is your labels. And this is your input, clean data, except that it can't be the input. The TF-IDF has to be the input. It's a vectorized form. Once you have the input as vectors, doc vectors column is here, the TF-IDF. You use as a, like you can basically, here's the doc vectors you created. Now for displaying, I put it in the pandas. You don't have to even put it in pandas. Here it is, right? Directly I used it here. First 7,000 rows I use for training, second 1,000 rows. Then I create a basic classifier. By the way, why multinomial NB? Go use whatever classifier you feel comfortable with, no reason. But then the rest of the lines, does it look very familiar, guys? You could do metrics.accuracy, metrics.whatever. I just use F1 score. F1 is what? Can somebody remind me what is an F1 score, guys?
Is it the harmonic mean?
Yes, it is a harmonic mean of precision and recall. Just think of it that it you think of a standard mean, right? It's just a different kind of mean. You may have learned in school the arithmetic mean, the geometric mean, the harmonic mean. So it is the harmonic mean of the two numbers. That is that. So 83%, which means that the topics are well separated out. Any questions here, guys, in this section? Are there any questions?
Asaf, can you quickly summarize precision and recall? I kind of get the gist of it, but I don't know the exact formula.
Oh, the exact. So I'll tell you guys, there's an excellent reference that you should use for this, where a picture speaks 1,000, like 1,000 words kind of a thing. Let's go here. Wikipedia precision recall. They have a lovely page for this. Do you see how it is given here? Now, please pay attention to this picture here. Suppose you have data. This side is the this side. Let's say that the left-hand side is made up of positive values. The actual ground truth is positive, and the gray area is negatives, right? True negatives. This is false negatives, means it's positive. So now look at this. You have true positives, false positives. Green is positives, true positives. This is false positive for a classifier. So what is precision? Precision is green over all the positives. So let's be very particular. Suppose you have a test and you need to determine how many cars, since you like cars, you're standing on a bridge and you have a little device that looks at the picture of a car going by and tells you whether it's a sports car or not. Yes, sir. Right? So your device will get, now let's say that a sports car actually does go by. Your device says it's a car. It's a sports car. True. That is an example of true positive, isn't it?
Yeah.
On the other hand, let us say a minivan goes by and you mark it as a sports car. So that is an example of false positive, isn't it? It is not really a sports car. So precision is how many of the things that you marked as sports car are actually sports car. Do you see that? Things that you marked as sports car, what proportion of them were correct, were genuinely sports car?
Right.
Are we together?
Yeah.
Right. And the recall is of the ones that you marked as sports car, right? How many sports cars went by and you couldn't detect them? So this area represents a true sports car. So let us say a nice convertible, a V8 engine went by and your instrument couldn't detect that it's a sports car, it missed it. So it is how many, recall is how many you caught versus how many there were, right? So of all the sports cars that went by, how many did you catch? That is your recall.
Got it.
Is the meaning now clear?
Yeah.
Right. So that is precision and recall. Keep this picture in your mind, guys. It's a very simple picture and it will help you. And it's really nice that actually of all the books that I have seen, I found this Wikipedia picture to be the simplest and nicest. Okay. So now guys, do these 4 lines of code, do they look easy? Are they straightforward? Anybody has needs clarification on this? This is straightforward. Zipf's law says, when applied to NLP and word frequencies, it says that the rank of so suppose you rank all the words by their frequency, the most frequent word being ranked 1, right? Which would be a word like or the or something like that. And the least frequent word that happens only once being ranked at the tail end, right? Having a much lower rank. Then it says that the frequency of a word is proportional to some power of the inverse of rank. Forget the power part, roughly speaking. The frequency is proportional to the inverse of the rank. If you ignore the power business, inverse of the rank means the bigger the rank, the smaller the frequency, and there's a 1 over R relationship. Now those relationships, they look a certain way. They look typically 1 over X relationships look like this. This is a Zipfian distribution kind of a look. Right. So is this, we're just checking whether this is true. And so all I'm doing is I'm making frequency plots and then plotting it out. So I'll let you stare on this for some time and tell me if anything looks odd here or needs explanation.
Asif, if this is not true, then what does it signify?
To me, it would signify that the words actually don't come from natural language. In other words, genuine language. They have been manufactured by a random generator. See, suppose you take a random generator to pop out words. what will happen? It will produce words with equal probability, right?
Yeah.
Right? Or you take any other distribution. So when you look at genuine text that people use, it tends to have, this is our observations. That law is not a law. In other words, it's just an observation based on human languages. It is so. See, think about it. How does a child learn language? The child in the beginning just picks up the important words. Mama, papa, hungry, food, whatever. It picks up some words, and then as the child grows, the vocabulary expands. But a natural expansion of the vocabulary is the child will pick up the most commonly used words first. And generally, a very limited set of words are sufficient for you to become capable of speaking a language. Right? If you really think about it, if you can pick up a few hundred words in a language, any language, you can pretty much become conversant, listen to that language, be immersed in it, and have a vocabulary of a couple of hundred words. You will survive, right? In other words, most things can be done with very few words. You don't need to learn the 5 million English words to survive in the US. As a person, I mean, we come from English-speaking countries, but if you look at people, I mean, I wouldn't call it Indian English. Indian English is a word, Hinglish. So we come from English-speaking world, which has an overlap with English. So we don't struggle. But if you look at people who come from non-native English speakers, I mean, different words like China or Korea or Japan, and you see how they learn. Their vocabulary in the beginning remains small and over time grows. And so they pick up vocabulary of only those words they need in the beginning. And gradually they expand out. So anyway, this is just verifying that it is roughly true in this corpus. Topic modeling with Gensim. So now what we do is we start modeling with Gensim, the topic. First of all, we want to figure out how many words are there and which ones to keep. So we define the words to keep as those words which are common enough, right? We remember, we threw away words which don't occur at least twice in the vocabulary. Rare words, you throw it away because it's too rare to have meaning. And then you have those words. You create a dictionary, a limited dictionary of only those words that you care about and that you find in your corpus. And once you have your own special dictionary, it turns out, and as you can clearly see, your own dictionary is a very small dictionary of not very small, but 28,000 unique words. There is a facility called filter extremes, which you could have used to remove common and rare words. Very common and very rare words, the two extremes. I didn't use it because we had already, as part of the data visualization here, we have already removed the stop words, and we have already removed the rare words. So finally, now actually down here, finally we come to topic modeling. Right? So how do we do that? It's very simple. 2-3 lines of code, that's all it takes. So here, first what we do is we take the words and we create a TF idea of vectorization of the word. So till now, the TF idea of vectorization we did it with Spacey, right? But now we can't. Gensim, again, this is a problem that you have to realize, that every library will have its own TF idea vectorizer. Scikit-learn has its own TF idea vectorizer, Gensim has its own, and then Spacey has its own, NLTK has its own. So you have to watch out. You can't feed one's vectorizer into the other. They are not expecting it, right? They're not compatible with each other. So here we are doing the very basic things. We create a bag of words and then we vectorize it. Gensim happens to need these 2 steps approach to do it. So here we go. We generate the TF IDF. Do we understand the thing, guys, right? TF IDF. Yeah. Simple. So we take the TF IDF vectorizer, apply it to the corpus, bag of words, and we get the TF-IDF. So any doubts in this code, guys? I'm only keeping those texts for text in the dictionary. For every line of text, we are creating a bag of words. And so you end up with a list of bag of words, and that would be our bag of words corpus. So remember, once again, to recapitulate, if you remember what a document is any body of text. That's why you have doc to bow. Bag of words was a simple vectorization that we talked on Monday. Every word, the only question you ask is it present or not? One hot encoding kind of a thinking, or then the frequency of the word and so on and so forth. You do that. And TF-IDF is basically saying, so bag of words is in that document, how often did a word appear and so forth. Now TF-IDF is, we talked about TF-IDF last time, so we won't do that. Term frequency, inverse document frequency. It gives you the sort of importance of a word based on how often it happens in a document and weighing in the uncommonness of the word. So that is it. So once you have that, you have TF-IDF vectorizer, you get the TF-IDF for the whole corpus. Then comes different ways of doing it. Last time I taught you latent semantic analysis, or LSI, another name for it is, and LDA, latent Dirichlet allocation, which is something, the inner details I haven't explained. I'll do that next time. Do that, and just as a reminder, these were the topics. So what do? I apply the model, very simple. Do you notice that? I apply the LSI model to this. It is almost like dot fit. If it was scikit-learn, it would have said LSI model dot fit. The corpus, and that is that.
Asif, can you explain the dictionary part from which you started from Gensim? The dictionary doc to bag of words.
Yeah. See, what is the dictionary? It is your vocabulary of actual words, isn't it? So what it does internally is, for all the words that are found, it attaches a index, right? A location. Because if you create a vector, let's say that there are 10 words in your vocabulary. So you will have a vector, you have to have array, right? With the indexing 0 to 9, isn't it? And each location, each index location is for one word, one of your 10 words.
Mm-hmm.
Are you understanding that?
Yeah.
Right. Okay. Let me just put it, draw it out, because I think you guys are forgetting the. Let me do that. One moment. I'm bringing up the writing pad.
Yeah, if you can explain, like, from the line where you said corpora.dictionary and then you included texts in it. So what does that mean?
Yes, I'm doing that. Give me a second. I will Alt H. Then we have this shared new. All right. Are you guys seeing my writing pad?
Yeah, I can see.
So let us say that you are here and you want to. So suppose you have a word. The only words in your vocabulary are cat. Okay, let's make it. Actually, this is the wrong thing I opened up. Give me a second, guys. Something odd happened. One note. Strange. I don't know what happened. Okay, something strange has happened on my machine. Yes. MLP. I have no idea why it is misbehaving. Okay, it's picking up the text very slowly. I don't know why, but so bear with me today. This tool seems to not always be perfect. Actually, I could use another one, whiteboard. All right, whiteboard is. There has to be a way to create a new document here, somewhere here. Okay. Create a new whiteboard. All right. With some luck, this will work. Suppose your words are cat, dog, horse, giraffe, zebra, right? These are the, and cow, let's say somewhere there, cow. Right? These are the only words in your dictionary. These are it's a zoo. And the only words you ever talk about are this. Right? Kids do that, right? When they grow up, quite often their vocabulary is filled with the names of all these cute animals. So then, suppose there's a sentence, cow, dog. Cow, dog, horse. A child says cow, dog, horse. How will you write it? You could write it like this. You know that you give to it the index 1, 2, 2, 3, 4, 5. You could say cow, 1, dog, 1, horse, 1, no cat, no giraffe, no zebra. Do you see this? This is your dog. This dog gets represented, this sentence gets represented as this particular thing, this vector. Am I making sense?
Yes.
Does that give sense to you? It is if I just created a vector in which for each of the location, each of the index location belongs to one of the words, right? So every word has an index location. Cow has 0, horse has 3. And then given a document, all you need to know is how often any one of the words have occurred. And you just go and update this vector.
So,
right?
So if the word is not in the dictionary, it won't be captured?
Yeah, that is the point. So that is why we created a dictionary. So the important thing is, create a dictionary, create your...
Oh, yeah, we actually created the dictionary. It's not some pre-made dictionary.
No, we created a dictionary out of the corpus.
Oh.
Remember
so when
that.
you say corporate or dictionary, it actually creates a
Yes,
list,
a unique dictionary.
a sorted list by whatever the code is in Gensim. It creates a sorted list.
That is right, essentially. Right? It gives the location. Basically, when you give it a corpus of words or documents, right? All it takes is that it finds the words, and then all it does is for each word, it first gives it an index location. Right? Do you see this? It gives it an index location. It says cow will be 0. So it will internally maintain something like cow, 1, cat. Do you get the idea? This is your dictionary.
Yeah, but I'm guessing the actual code or the actual mechanics of that dictionary is pretty complicated, right?
Oh, yeah. Internally, you don't want to because it's a sparse. Yeah, there's a little bit more going on. You can read the code. It's not very complicated, but there's a little bit more happening than at the conceptual level that I explained.
Okay.
And this doc that you saw is essentially your bag of words. Like if you look at this doc, this is a doc, right?
But it is not vectorizing, right? It is not vectorizing.
It is a vector. No? Look at this. What is this?
But don't we vectorize it afterwards?
So there are many different representations. No? Remember I said that the vector space representation last time. By the way, were you there on Monday?
Yeah, I was. I'm just trying to understand. So right now, I think it just gives a index, right? But doesn't create the TF-IDF or one-hot encoding or anything.
So vector space representation. Here's a summary again. Vector space representation. What it means is you take a string of dog, cow jumped over the moon. Well, here, since those words are not there in our vocabulary, let me just use cow, cow, dog, horse. This is a sentence. The purpose is to take this sentence and uniquely map it to a vector. What is a vector? In simple terms, for computer scientists, it's an array of fixed length, isn't it? List of fixed length. So there are many ways you can do it. The question is, first of all, the indexing is, this is the 0th index, one index in an array. You know, this is how you index the array, isn't it? That is simple to you, right? You realize that arrays are indexed by this notation. If I give you a list and you say 3, what does it mean? It is the 4th element in that list, right? So indexing is given. And now the question is, how do I map this sentence to this to make it into a vector? Because this now, for example, belongs to a 5-dimensional space, right? This is a vector in 5-dimensional space. So long as I put numbers in these locations, floating point numbers in these locations, I can do that. One easy way is just count the frequency of each of the words. So cow was there. Dog was also there. Cat was not there. Then let's say horse was not, horse is there in the sentence. So here we go. 1 here. And then let's say giraffe was not there and zebra was not there. And say, suppose I extend this sentence to dog, horse, dog. Then what happens? Where is dog? 2. 2 location. So I convert, well, okay, that is confusing. Let me not have 2 dogs because it will look dog. Let me just make it cow again. Cow. So what happens? The cow location now becomes 2. Right? Do you see that this is a vector? Guys, do you all see that, right? It's a vector, it's an array. It's a list of fixed size. It is a point in a 5-dimensional space here. Word space.
So it
Now,
gets it into a vector which can be used by the TF-IDF vector.
Yes, exactly. And now, so this is a halfway station. This vector is your bag of words, bow, bag of words in a way. And in a way, you know, what you can do, what people do is they don't associate too much, like there's no order associated. So internally, you don't want to store all these zeros because that leads to very inefficient storage. So you might just keep it as a hash map. You can just say only the locations that do exist. For example, 0 maps to 2, right? 1 location has nothing, a 2 location has 1, and a 3 location has 1. So when you represent this with this, the same thing as this, do you realize that a map is a much shorter way of representing it? You're not keeping all the zeros there, right? You're only keeping the non-zero values. You can keep it as a, so that is called a sparse representation of a vector. The way you think of a vector as an array is a dense representation of a vector. And a sparse is like a dictionary, like a hash map. Are we together? And now from this, another representation that you can get is you can get a TF-IDF representation, right? TF-IDF vector. From the bag of words, if I have a bag of words representation for every document in the corpus, then I can, for each of these documents, now for cow, dog, horse, cow, I can produce the same 5-dimensional vector, but now the values would be the TF-IDF values. Term frequency, inverse document frequency, let's say 3, 1, whatever it is, those. You'll have to compute that, but okay, that's that. Am I making sense now?
Yeah, so as if that TF-IDF, you have 2 lines. You have one with models.tf-IDF where you're using the corpus.
The TF-IDF models, the TF-IDF just creates the TF-IDF vectorizer. Actually, the API is much cleaner for scikit-learn. Can I show you the same code for scikit-learn for a moment? Right? Because in my view, right, Gensim, the notation it uses is a bit confusing. Let me show this thing. It will be more, and this is one of the things, you know, every guy uses his own notation. their library becomes popular. Now you have to get used to their stuff. So let me show you the same thing, how it is done. For example, I think scikit-learn is always excellent in clarity of its notation. sklearn TF Idf vectorizer. See, let's look at an example of vectorizer. User guide. Let's go to the user guide. Do you notice that given a corpus, so here it is. This is a corpus of text documents. I'll increase the fonts a little bit. Just pay attention to this paragraph of code. We'll pay attention to this. Right. Now, what are we doing? This is a corpus. We agree, this array of text. Each text is a document. Nisarg, are you getting this?
Yeah.
Then we use the simple count vectorizer, your bag of words kind of vectorizer, and you fit it to this. So you will get a representation the way I explained it to you. Then you can do more. You can go to the TF IDF. You can even do bigrams and so forth using stop words. Now here is the TF IDF. It explains it, but forget that we already know the explanation.
The bigrams and stuff would happen before, right? Before vectorization.
No, we haven't done that. Forget bigrams for the time being. They just add to the vocabulary. Just focus on the words. Now think about the TF IDF vectorizer. Do you know there's a TF IDF word is here? And forget all this long explanation. And what it does is it helps you create hang on, we need to look at some using sparse features. Some code, example code. Yeah. Vectorizer, fit vectorizer, count, fit transform. Okay, the example, this is not a very illustrative page. Let us go to another page that shows you a good succinct example. We don't want to read so much here. Okay. So look at this. You have a TF vectorizer, right? You can create a TF vectorizer here, count vectorizer, and so on and so forth. And then how do you create a TF IDF vectorizer? You can again give the thing. You create the vectorizer instance. You haven't used it. You have to fit it to the training data. When you fit it to the data, it becomes what you want it to be. Right? So you instantiate it. So now coming back to it, this line, where am I? This line, therefore, what is it doing? It's just instantiating your TF IDF vectorizer. They call it the TF IDF model. Right? And then you apply it, you get the TF IDF on the bag of words. So it's just a strange syntax. That's all it is. So I hope by now I've clarified. So read the documentation in this. It will clarify it. It's just Gensim's own language. The latent semantic analysis is the model, the SVD-based model. You create the model, and again, it has this syntax, which is odd. It's unlike scikit-learn would have written a slightly cleaner syntax, but for what it is worth, it is. The creators of this library made it like this. So that's that. So now does it make sense? All you're doing is you're giving it the corpus to a model, to a machine learning model, to do unsupervised learning, to discover topics in it. Right? And then you ask it to show you the topics, and it shows you the topics. Right? And it shows how the topics are made up of the words, the important words they are made up of. Right? So far, so good, guys. Right? So it's 10 o'clock. Let me wind this down. Nisarg, are you getting this?
Yeah.
Straightforward. And the same thing you could have done LDA from a coding perspective is just a change of word instead of LSI. you change it to LDA word. You change one word and you repeat the same thing. Except that these two algorithms are far different. LDA is a very powerful algorithm. Right. Then there's a measure. How do you know how good your model is? You can do the model perplexity. Now I invite you to read the documentation on this and on Coherence Score. Right? Coherence Score is often used. Now this visualization tool is very good. It helps you see how good a model you built. It is okay. I wouldn't call it terribly good. You can improve upon it. 1 and 4 seem to be well separated out. 2, 3, 5, 6 are pretty close to each other. Then I suggested that use Mallet. Mallet generally outperforms Gensim's built-in. When you do Mallet, you get a separation like that, which looks cleaner, much more separated out. And that is that, guys. That is it. That's sort of your detailed walk through the lab. So guys, here's the thing. At this moment, I would strongly suggest, if you have not given time to reading the Spacey book, you must. We are 2 weeks into the NLP workshop. I'm going to go into deeper topics now. I'm going to go into, next time would be the word embeddings in detail. And then the week after that, the next 3 weeks will be all transformers, because the world has changed. It's all about transformers now. And we'll be introducing more and more libraries. I'll bring in Hugging Faces and so forth. So transformers. And we'll do a lot of code. This part 2 is all about hands-on coding. So we didn't get time to get to the project. Maybe next time we'll talk about it, or on Saturday we'll talk about it. Guys, if you want to get most out of this workshop, do the labs and do the project. And read that book. Spacey book you can actually finish in 2-3 days. Do it. Right? Or you don't like the book, go to the website and just read the documentation. It's very well documented. Likewise, go to the Gensim website and read the documentation. Any questions, guys? By the way, I got the feeling that you all are struggling a lot today. Was it really hard understanding this lab? Any feedback, guys?
No, Asif.
Is the code looking straightforward, or it looking very strange? Praveen, thanks for that feedback. Anybody else? Shiva, how did you find it?
No, it's not too difficult. The only thing is a lack of practice. That's what.
Yeah, you need to practice it. Read the book, guys. Practice it. See, guys, anyway, I'll stop the recording here because we are taking names now.
Conceptually, you explained really well. So I mean, it's not too difficult to get it. But
Yeah. Thank you. See, guys, here's the thing. Like, you guys are working hard, I'm sure. It takes, from me too, it takes a lot of effort. At the end of it, my real reward is, as you know, at this moment, this is a break-even business. It's sort of not really a for-profit business, right? It's because I like teaching and I've been teaching for 30 years. I'm just continuing that. But what is my reward? My reward is to see you guys succeed. Yeah. And no matter how much I teach, at the end of it, it comes to practice. If you don't practice, you won't get there. Yeah. So I don't get the satisfaction unless you guys succeed. And I can clearly see, I mean, through 30 years of teaching, many things I've taught calculus, I've taught physics. And I've taught graduate courses in theoretical physics and nuclear physics and so forth. And over the years, and I've taught computer science, and I've taught graduate computer science, and all these years of teaching. The one constant that remains is hours. Generally, people in engineering are very, very bright. Their IQ is above that of the common population. There is no doubt about that. especially the sort of audience we have here. By definition, these you guys are self-motivated, motivated enough to give your evenings away from your family and be here in the sessions, and motivated enough to want to learn these topics. That itself puts you in a pretty top tier category. So intelligence and motivation is not in doubt. So the only factor that remains is the number of hours you put in. And success consistently has been almost a direct function of only one variable: number of hours you put into this. So please put in the hours and practice. Then you'll get a lot out of this course and these workshops. And I would love to see you guys come January be achieving your dreams, whatever brought you here to support vectors, going out there and achieving it. Either moving on to interesting projects inside your company, looking for a job change, getting into graduate school, whatever your goals are. There are people who came here to start companies, and they have started companies. One guy has, his revenue apparently has already crossed 30 million. Yeah. He started with me about 3-4 years ago, and so forth. So those are the successes you cherish, you look forward to. And that comes when you put in the effort. So please, if I can say, you guys, we all live professional, busy lives as parents, as professionals. So time is a rare commodity. But see if you guys can devote more time to the labs. It's very important. Do the book, do the labs. Then you'll feel very confident with all of this. These are not hard. It's just that we are moving fast, and every week we introduce new things. So it is new. And by the time you catch up or try to catch up, we already moved on to the next topic, isn't it? And the nature of this workshop is it keeps moving on relentlessly from topic to topic, because we have the whole of AI to cover, the neural network and the NLP and image processing and anomaly detection and time series. We have a pretty large landscape to cover, and it will keep moving on at a brisk pace. And it's very interesting. People who come to support vectors quite often say, why does it take 3 months or 4 months or 5 months to learn this stuff? Why can't we just learn it in, sometimes it's ridiculous, over the weekend, or maybe in 1 week or 2 weeks. And so there are people who want to learn it all in a hurry, but at the same time, it is a vast subject. We are moving as fast as we can. Right? I can see that this pace itself is hard to keep up. But you have to try to keep up, otherwise we'll miss the topic. All right, guys, that's all I have. Any questions, any feedback? Otherwise, I'll close for today.
So as if we didn't go over the project, right?
Yeah, we didn't. And let's keep it. It's 10:10, 10:11. Actually, I need to get into my India meetings in a bit. But generally, I'd like to, guys, get started. Let's do it over Saturday. Let's make progress on the project. And this Saturday, I was going to do the Java version of the microservice. You often take code to production in Java or Scala or Kotlin or C or C++. These are the production level languages quite often. Okay? So how do you take a model you have built it in Python and then run it in a high performance environment? That itself is an interesting topic. I think somebody requested I don't do it this Saturday. You guys are busy. Do it next Saturday, but I'd like to do it next Saturday. This Saturday, we'll do the quiz review. I'll release the topic modeling quiz and do that, and we'll review that. And then in the afternoon, we'll give time to project reviews. Huh? Let me help you guys with your projects. Does that sound fair? And then on Sunday, we will do our research paper reading, the one that got postponed. All right, guys, that's all I have. So unless there are more questions, I'll stop the session.
Yeah, sir.
Yeah, go ahead.
No, it's just thank you.
Oh,
thank you. All right. Good night, Asif.
Good night and bye.
Thank you, Asif. Good night.
Good night.
Thank you, Asif. Good night.
Bye.
Asif, take care of your health.
Yes,
Get some more sleep. Yeah, get some more sleep and fluids.
yes, I should.
They look actually sleep deprived.
Yeah. How are you doing, Patrick? Is your project moving along fine?
We were supposed to meet Tuesday, as if, but because of it was election day, we were gonna meet on Friday. So we'll meet tomorrow. So we'll probably we'll see what we can get out by Saturday. Yeah. And then so I guess I didn't want to ask the question asked, but so I had something, just a simple question. What if your word actually had more than one meaning, but
that is the problem. That's why we'll go to the problem with IDF is it doesn't deal with the context and the different meanings of a word. It's a very primitive tool, right?
That's what I
Remember
thought.
in ML 400, the first part, we learned about word embeddings and contextual word embeddings, the transformer-based word embeddings, word-based. So we are coming to that in detail now.
Nice.
See, everything that we learn, you know, is small steps. First, you have to learn the old way, then you learn a more powerful way, then a more powerful way. So now I'm taking you slowly through that journey. But if you go back and look at your notes of the 1 week that we did in NLP, we went fast, but I actually took you through the whole journey in 1 week that we are now doing carefully in 6 weeks.
No, I really appreciate that, Asif. And your explanations are really they're very good enough. They're profound enough, and it's easy. I wouldn't say simple, but it can carry me through. Coming from a not so math heavy background, so I'm really thankful that you're able to teach it that way. Yeah. So yeah, and for me to ask that question about the multiple meanings, because I wanted to reference the word jump in our last quiz, right? You had jump as a noun and then jump also as a verb.
Yeah.
So that's what I was going to ask in the bag of words, because if it's context aware, it'll be able to pick up both the noun and the verb. But it didn't sound like the bag of words or the TF-IDF was at that level where you can discriminate.
Yes.
But yeah. No. Thanks for clarifying, Asif. And yeah, I'll finish the book over the weekend so I can catch up to speed. But I've been looking through the code and it's been very helpful, Asif. Thank you.
Sir, you're welcome.
And please take care of your health, Asif. Yeah, please do. Okay. Thank you so much. I won't bother you now. Anyway, good night.
Night.